Welcome to Lie-Nielsen Toolworks. Visitors to our shop are always impressed by the amount of work that goes into making these hand tools. We do them in small batches. We're not a large production shop, and there's a lot of handwork involved in every step along the way. So every person who touches the part or the tool is part of the process of producing the quality that we do here. I'd like to give you an opportunity to have a glimpse of what goes on in our shop here in Warren. I think you'll be impressed. In order to make a casting, you need a pattern. We make all of our patterns by hand. We use a combination of wood, plastic, and metal to get the shape that we want. Sand casting has been around for thousands of years. It's relatively straightforward. You have a pattern, which is a shape of the object that you want. You pack that into what's called a flask. A flask is a two-part box, comes apart. You fill the bottom part with sand and put your pattern into that sand to make an impression. Our iron castings are molded by hand. And this gives the molder the opportunity to sift finer sand against the pattern, which results in a much nicer surface texture of the finished casting. You put the match plate in between the two halves of the flask. You pack the bottom half with sand until it's quite hard. Once you have the top off, you then pull the match plate out of the bottom of the mold. This results in a cavity in the sand that is split along the horizontal axis of the part. There are two patterns on the match plate. So if you need 100 castings, you have to do this 50 times. The molders are molding until they get enough molds ready to pour. I've been doing business with Enterprise Foundry for many years, and they specialize in ductile iron. Ductile iron is a type of iron that's been treated with magnesium in order to make it ductile, which means that it will bend and not break. The furnace holds 3,000 pounds of metal and is able to reach the temperature of almost 3,000 degrees every 45 minutes. So they tap off about 1,000 pounds each time they pour. The iron is treated with manganese just before pouring. It's put in the molten iron and stirred, and then anytime that you melt metal, you're going to get oxides or slag, so the crucible full of molten metal has to be cleared of slag, which floats to the top, so they'll slag it off. Just before pouring, you will notice that there is a small sample being dipped out of the crucible, and that is sent to the lab for analysis. And at Enterprise, because 1,000 pounds is pretty awkward to handle, they pour off the 1,000-pound crucible into smaller crucibles, which hold a few hundred pounds apiece, that one man can manage. When they're ready to pour, everybody from all over the shop who have other jobs other than molding converge on the pouring area. Pouring the metal into the mold is at least as important as all the other variables involved. In the period when I started making tools, nobody stress relieved anymore. But one of the things I like to do is to leave the casting in the mold overnight so it cools off as slowly as possible. The other thing that we do with all of our castings is to heat treat them or stress relieve them by heat. After they're cut off of the tree, so they're put into an oven and heated up to a very hot temperature, and then they're cooled off, and the cooling off slowly is the most important part. So we take a lot of care in this process and have not had problems with castings that don't stay flat because there's stress in them. It's possible to introduce stress in the grinding or machining stage, which is why we use the this old-fashioned horizontal milling machine to open up the base. It's a fairly heavy cut off the big castings, and I want to do that as slowly as possible. We'll machine the sides square to the base with a carbide insert end mill. And at that point, there's a little bit of work done buffing and polishing the outside edges of the tool, and then if it's an iron casting, it's powder coated with black paint. That's a very durable finish, which is baked on about 450 degrees. We move on to the CNC equipment with more modern tooling when we're doing the smaller milling operations on the inside of the casting. We are a relatively small volume producer of hand tools. So there are some operations that we do by hand because it makes sense in terms of time and quality, and then it's ready to grind. Grinding being the final finishing operation for the actual body of the tool. And we're looking to grind our planes flat and square within 1/1000th of an inch, regardless of the size of the tool. Most of the machining on the bench plane frogs is done on the CNC milling machine, computer-controlled milling machine. That's an efficient way to get the volume that we need and the precision that we need. There are 4 stations in the CNC, and each part is moved from one station to the next as the operations are completed. And at the end, there's a finished frog that comes off the machine and goes to polish to be finished in polishing. The CNC allows us the precision, accuracy, and the ability to do numerous operations in one environment. With cap irons, lever caps, we do some machining on the CNC and then finish them on the Bridgeport, hand machining, and then hand assembly of the parts. There are 5 parts in a lever cap, 2 castings, 2 rivets, and a spring. Those are put together by hand, and then the final assembly is polished and tumbled to give it a final smooth, burr-free finish. When I started, I wanted to have Native American hardwoods for the handle. We take the raw material, we shape the handle in a computer-controlled machine, and then we spend a fair amount of effort, particularly with saw handles and plane handles, hand shaping them so that there aren't any hard surfaces, sharp corners, so that it fits comfortably in your hand, it feels smooth, and it looks really good. Heat treating is a multi-part process. There's hardening, where you heat the steel up very hot and you quench it. And the object of heat treating at that point is to get it as hard as possible. So you'll get a result around 64, 65 Rockwell, which is too hard to be usable. We also discovered in our research that A2 steel and some other materials respond well to cryogenic treatment. And cryogenic treatment is when you take it, pour liquid nitrogen in there and get it down to 356 degrees below zero and hold it there for a while and slowly bring it back up to room temperature. What this does is, with A2 steel, in my opinion, is it kind of perfects the heat treating process. The next part of the process is called tempering, and that's where you heat the blade up again to a lower temperature, which will give you the Rockwell hardness you're looking for. We're looking for 62. Blades are ground on their top and bottom and the bevel, And before they're actually finished, we buff around all of the edges that are not the actual cutting edge of the blade to soften it, to make it more friendly to the hand, and to provide what is a finished blade. Everything comes together in assembly. And one of the interesting things about assembly is that we're doing a variety of tools every day. But a lot of the time, an order will go directly from finishing in the shop to assembly and shipping. And it can happen within a few hours.